When does a machine stop being a machine? Boston Dynamics' Atlas robot doesn't just walk. It sprints, flips, and breakdances with an uncanny grace that's left engineers speechless. The line between human and machine movement is vanishing, and it's happening faster than anyone predicted. Atlas represents the cutting edge of humanoid robotics, a 1.5-meter-tall marvel of engineering that moves with startling fluidity. With each software update, this hydraulic powerhouse is redefining what robots can do physically, pushing technological boundaries that were considered science fiction just a decade ago. The moment Atlas performed its first backflip in 2017, something shifted in our collective consciousness. Engineers celebrated, but for many people, an alarm bell rang. There's something deeply unsettling about watching a machine move with such biological authenticity, not just mimicking human movement, but in some ways surpassing it. This discomfort isn't irrational. Our brains are hardwired to recognize human movement patterns. It's a fundamental social skill. When robots breach this territory, they trigger a response that anthropologists call the uncanny valley, that eerie feeling when something appears almost human, but not quite. Beyond the psychological reaction lies a web of valid concerns. As Atlas and its mechanical siblings grow more physically capable, questions of security, employment, and control become increasingly urgent. A robot that can sprint, climb, and navigate complex terrain could potentially access spaces designed exclusively for humans. What safeguards exist to prevent misuse? Then there's the economic dimension. Boston Dynamics insists their robots are designed to handle dull, dirty, and dangerous jobs, not to replace workers. But when a machine can move with human-like dexterity while offering tireless performance, which jobs remain uniquely human? Perhaps most concerning is the philosophical challenge. For centuries, movement has been central to our human identity. We've defined ourselves partly by our unique physical capabilities, our ability to dance, climb, and create with our hands. As robots master these distinctly human domains, we're forced to reconsider what makes us special. The ethical frameworks for managing these machines simply haven't kept pace with the technology. While Boston Dynamics and other robotics companies signed a pledge against weaponizing their creations, these remain voluntary commitments without legal enforcement. Beneath Atlas's smooth exterior lies a marvel of engineering that's as complex as it is elegant. Standing 1.5 meters tall and weighing roughly 89 kilograms, Atlas is powered by a sophisticated hydraulic system, 28 custom hydraulic joints that provide the robot with its remarkable range of motion. But the true revolution isn't in Atlas's hardware, it's in how it learns to move. Boston Dynamics has shifted from traditional programming to reinforcement learning, a form of machine learning where the robot essentially teaches itself through trial and error. Engineers create virtual simulations where thousands of Atlas models attempt movements simultaneously. Those that succeed receive digital rewards, gradually refining their technique until they've mastered the task. This approach represents a fundamental shift in robotics. Rather than explicitly programming every movement, lift leg 30 degrees, shift weight forward, Atlas understands goals. Get from point A to point B, or pick up that box. The robot then determines the optimal way to accomplish these tasks based on its learned experience. Atlas's perception system is equally impressive. Using depth-sensing cameras and LiDAR technology, it creates a three-dimensional map of its surroundings 30 times per second. This spatial awareness allows Atlas to navigate uneven terrain, avoid obstacles, and make split-second adjustments to maintain balance, much like a human would. The robot's newest iteration runs on NVIDIA's Jetson Thor computing platform, which processes this torrent of sensory data in real time. This computational muscle, combined with Boston Dynamics' proprietary control algorithms, enables Atlas to make up to 500 micro-adjustments per second to stay balanced, far faster than human reflexes. Perhaps most remarkable is Atlas's ability to recover from disruptions. When pushed, pulled, or forced off balance, the robot instinctively adjusts its posture to prevent falling. It redistributes weight, extends limbs as counterbalances, and shifts its center of gravity. all without explicit instructions for these specific scenarios. This adaptability comes from a principle called model predictive control. Atlas continuously forecasts how its body will respond seconds into the future, allowing it to preemptively adjust for changes in terrain or balance. It's the same unconscious process that allows humans to walk without constantly thinking about each step, except Atlas performs these calculations with mathematical precision. The result is a machine that doesn't just imitate human movement, it embodies the underlying principles that make our movements fluid and adaptable. The watershed moment came in August 2023, during a routine demonstration at Boston Dynamics testing facility. Atlas was running through a parkour routine, jumping between platforms, vaulting obstacles, and performing synchronized movements with a second robot. Impressive, but nothing the public hadn't seen before. Then, something unexpected happened. A researcher deliberately placed an unfamiliar object, a backpack, in Atlas's path. The robot paused momentarily, assessed the obstacle, and rather than following its programmed routine of jumping over it, Atlas made an unexpected choice. It reached down, grasped the backpack by its strap, moved it aside with a casual flick of its wrist, and continued its course. This seemingly minor deviation revealed something profound. Atlas had not been programmed to move objects that blocked its path. It had learned, through reinforcement training, that moving obstacles was sometimes more efficient than jumping over them. The robot had improvised. The clip went viral, amassing over 50 million views within days. Comments ranged from admiration to genuine unease. "That wasn't programmed. That was a decision," wrote one viewer. The casual, almost irritated way Atlas had moved the backpack struck many as eerily human, reminiscent of how a person might react to an unexpected obstruction. Engineers explained the behavior as merely advanced problem-solving, but the public reaction revealed a deeper truth. We instinctively recognize intent in movement. When Atlas shifted that backpack, viewers didn't see a machine executing code. They saw purpose, impatience, even personality. This moment crystallized both the promise and the challenge of advanced robotics. The same adaptability that makes Atlas valuable in disaster response scenarios, its ability to navigate unpredictable environments, also makes its behavior less predictable, less mechanical, and consequently, more unsettling. Boston Dynamics later revealed this capability was part of a new environmental interaction protocol, allowing Atlas to manipulate objects it encounters rather than simply avoiding them. A practical enhancement certainly, but one that blurred the already fading line between programmed behavior and something that looks remarkably like independent decision-making. Atlas represents both the pinnacle of robotic achievement and a mirror reflecting our anxieties about technology. As these machines continue to master human-like movement, we face a future that demands not just technological innovation, but thoughtful consideration of what boundaries, if any, should remain between human and machine. Have you seen Atlas in action, and did you feel that flicker of unease? Share your thoughts below on whether we're moving too fast or not fast enough. Then check out our video on Tesla's Optimus robot to see the commercial future of humanoid machines.